Morning, everybody. So today I'm going to work on showing you how to do the chi-squared test for independence. Now, there are a couple triggers between the chi-squared test that you use the goodness of fit with and the chi-squared test for independence. So typically, the independence one will have a table that looks something like this. And then the other piece is that in the statement, you're going to see the word related or the word dependent or the word independent. Before we begin and before we dive into the problem, the first thing we need to be able to do is, and I say we, the calculator will do this for us, but there are times where Alex will ask you to develop the thing called the expected value for the cell. And there was an expected value in the other goodness of fit process as well. So, forgive me. To get the expected value for the first cell here where the 20 is, and I have this written down here so you can screenshot it if you need to, it's going to be the row total, and the row total is 50, multiplied by the column total, which is the 60, divided by the total. And that gets you 28.57-ish. I rounded, truncated to the second decimal place. To get the expected value here, you'd go the row total of 50 multiplied by the column total of 55 divided by the total, and then that's the 26.19. And then the cell here where the 25 is, the row total is 40, the column total is 60, so it's 40 times 60, and then you're dividing by the 105, and that gets you the 22.86. And so you do that for all the cells in what I would refer to as the body of the matrix. So I'm going to highlight the body. This is the space that doesn't include the totals. And you need to recognize this because when we use the calculator, it's the body of the matrix that we will plug in. All right. So as a reminder, the sum, or the chi-squared test statistic, and the way we write this is this capital X with this little square over there, is equal to the sum of, and I've seen it written in two ways. You can see it as observed minus expected squared, and sometimes you'll see expected minus observed, but observed minus expected divided by the expected. And so I'm just going to do one cell of this. So the observed value is 20. So what we would do is we would write 20, I'll do two cells now that I say this, minus the expected, which is the 28.57. And then that's going to be squared, and then it's divided by the expected, which is 28.57. And then this summation here, it tells us to add on the next relationship, and that's going to be observed is 30, and then minus, and you take the expected value, which is the 26.19. I hope I didn't cover that up and write that wrong. Okay, but it's 26.19 as I see it. And then you divide it by the 26.19. And then you add on because of the summation symbol. And you do that for each of the cells in the body. And then you'll get your chi-squared test statistic. Now, our calculators are all set up to be able to do this. The goodness of fit, about half the calculators won't have it. So it's one that's required we do it by hand. I'm just cleaning up the mess now. So we're seeing how we get the test statistic. Now we're going to run the test, and I'm going to have to show you how to get The critical value based on the table, I'll have to call that up and show you where that's at in our e-learning. So it's a little bit of teaching you where stuff is as well as process. So let me go here real quick. Actually, I might have it in let me just check this very fast. I want to see its table. There it is. There it is. Got it. I'll just call that up here. All right. So the first thing when we read this is we see that we're trying to see, is there support for the bill related to or dependent on party affiliation. So that's the terminology that we get when we are looking for the independence case. Now, our null and our alternative are prescribed. And what I mean by that is these are pretty much just set. So what we're going to say is in the null, they are independent. And then in the alternative, you'd put related or dependent. And then you just have to figure out which one gets the claim. So is the support for the bill related? Since they're asking that, the claim will sit on the alternative hypothesis. Okay. And as I had said in the previous video, all of the hypothesis tests that we are dealing with after after the two-tailed stuff, I should say it that way, are right-tailed tests. So we have reject the null out here, and we have a fail to reject the null here. Okay? This is a 0, and we need to figure out what this value is, our critical value. Now, to do that, all right, we look at the body of the table. We do not include the totals when we're doing this. And we take the number of rows minus 1, and we multiply that by the number of columns minus 1, and that value is going to give us our degrees of freedom. Okay, so we have 3 rows and we have 2 columns. So it's going to be 3 minus 1 multiplied by 2 minus 1. So our degrees of freedom will end up being equal to 2. Now I'm going to click on the table. And this is the same table that is in the content tab in your e-learning website. So in the content tab, you go about almost down to the bottom, and it'll say table for the or tables for the hypothesis tests. And so you're looking for the chi-squared distribution table, and our degrees of freedom are 2, and our alpha is 0.10, so our critical value is 4.605. I hope you see that again. So here's the degrees of freedom. Here's our level of significance, 0.10. Here is the 4.605. Okay, so this value here is 4.605. Now, getting this bit into the calculator is a bit of a process. So bear with, and it's going to take a second. And this is what I was talking about earlier. So the first thing you have to do is you have to find your matrix key. Now, for the 84s that are newer, the matrix key is the second key, and then you go about 4 keys down from there, and you'll see matrix. for the older 84s and the 83s, there's actually a matrix key that just says straight up matrix. What you will do is the following. You are going to hit the second key and the matrix button. Now, you're going to see along the top. I'm going to call up a new sheet of paper, and so we can sort of demo it. Here's a new document. Okay. What you're going to see up at the top, when you hit the second key and then the matrix key, you're going to see names, math, and edit. And then you're going to see this 1, and then you're going to have this A, and then you're going to see some form of like 1 by 1 or something of that nature. And then you're going to see a 2, and then you're going to see matrix B, and then it might be blank following, and it might, if somebody's put something in there, you might see like a 2 by 3 in there. That's all good. Don't stress by any of that. And you get a third one, and on my screen I get down to a 7th one. You probably have similar. What we're going to do is we're going to highlight edit and hit enter on edit. So you want to highlight edit, hit enter there. So you hit enter on edit. What you're going to see at that point in time is a screen that will read matrix, and then it will identify the matrix that you're working with. So you can select a different matrix, but I suggest that you put it in A. It just is easier. Now, you're going to see this like set of numbers, and it goes rows, then columns. So we have 3 rows, and we have 2 columns. So we want to change ours to a 3 by 2. So you have to arrow through and get it so it reads 3 by 2. And you'll notice that the by, the multiplication symbol, is closer to the second number than it is to the first number. Now, you're going to see this after you hit enter there, you're going to see the cursor inside the matrix. You are only going to put in these values in the body. Do not put the totals in. I'll say it again. Do not put totals in. The calculator will do the totals and the expected values for us. It'll take care of all of the work that I showed you. All right, so we're going to put in the 20. So that's our first cell. So type the 20, then hit enter. When you hit enter, it will automatically move it over to the second spot looking for the value that you need to put in. So now you're going to type the 30. You are going to hit enter. It will move you down to that next cell that you need to put in, which is the 25. Then you hit enter, and when you hit enter, it will move you over to where the 15 is. Then you hit 15 and you hit enter. You can, once you're done putting all of the stuff in, move around with the arrow pad. So you can move around in there. So just give it a shot and see if you can kind of float around just hitting the arrow pad keys. But you'll fill it out. Make sure it matches. To get the number to actually be there, you've got to hit enter. Okay, so you should have it looking like that. All right, now what you're going to need to do is you're going to need to hit the second key and then quit. Now the second key is, you know where the second key is, it's top left. Quit is right next to it. It's the mode key. So we're going to hit second quit. We're leaving that screen. Now, we've got the data entered. That's what all of this stuff is right here. We entered in the data. Now you're going to need to hit the stat key, and you're going to need to arrow over to tests. So hit the stat key, arrow over to tests, and you need to look for the chi-squared test. Now I'm going to draw this. So there are two that you will see potentially. Some calculators only have one. All right, so you are looking for what is referenced as chi-squared test. There are some calculators that will have the chi-squared, and it'll say GOF test, the goodness of fit test. Because only about half of the calculators have this, this is part of the reason why we do the goodness of fit test by hand. In saying that, we also do it by hand because it's a good representation of really what's going on with hypothesis testing. Hypothesis testing is an accumulation of error, like how far off are we? And so if we're not very far off, the null hypothesis gets supported. If we're very far off, the alternative hypothesis gets supported. And so that's just developing the sense of hypothesis testing. So you're going to hit enter on the chi-squared test. So we hit enter on the chi-squared test. Now, I think there's actually a third one that sometimes appears where it says goodness of fit test, and then there's the chi-squared test, but it's got another name with it. Don't do the goodness of fit test. Do the other one if that's the case. Okay, so hit the chi-squared test, and you're going to see observed. Let me delete this. You're going to see observed, and you're going to see expected. I'll type this in if I can. All right. There we go. Now I'm going to go over there. No, I don't want that. I want this. I want that. Okay. You're going to see observed. And then they're going to have this A. And then you're going to have this expected. And then you're going to see B. All right. Observed is the matrix that you put the stuff in. So if you put it in A, it should read A. If you put it in B, it should read B. If you put it in C, it should read C, and so forth. Expected is what the computer built. And so you don't do anything with this. You leave the expected one alone. Then you arrow down to calculate. And there isn't anything for you to do really on the screen other than arrow down to calculate. It's just making sure that it selected the correct matrix. Anyways, hit calculate. And what you're going to get is you're going to get out of this a chi-squared value, which is actually all of the stuff that we had shown here previous in there added up. So we get 5.29, and we get a p-value, which is 0.07. All right, so let's go back over here and let's do some comparisons. The 5.29, think about this bottom as a number line, and I will do a little bit of color work here. So 5.29, if this is 0, then here's the 1, here's the 2, here's the 3, here's the 4, there's your 4.6, and over here somewhere is your 5.29. So the test statistic is landing in the rejection region. And the next thing is that our p-value is smaller than our alpha. So if it's smaller than our alpha, we are rejecting the null. Okay, so our three components are, we're going to reject the null. And then the second thing we state is our level of significance. So our alpha is 0.10. Now let's travel back here and remember that we are rejecting the null, and it just so happens that the claim is on the alternative. So What happened there? Not really sure. Okay, so we had reject the null. We had our alpha is equal to 0.10, and then the third thing, and what I was trying to get at, was that the claim is getting supported. So the data, I don't know why it's doing that. So the data supports and ... It supports the claim and so forth. Okay, hopefully that helps. Have a good one.